Hi, welcome to my YouTube channel. Today we will be solving the question swap nodes in pairs. So we are given a single linked list and we have to swap every two adjacent nodes and return its head. And we must solve the problem without modifying the values in the nodes, and we have to update the pointers rather than overwriting the nodes. So let's have a look at an example and see how we can solve this problem. So here we have this linked list of length 4 and we have to swap adjacent two nodes. So in the beginning we have this node 1 and node 2 and the head points to node 1, and we have to swap these nodes 1 and 2. So after swapping, node 2 will come before node 1 and node 1 will come before node 3. So because this problem involves using previous pointers, that is why I have created a dummy node here. So let's call the two pair of nodes as P1 and P2. So this problem is same as swapping nodes in a linked list that we saw before. So where we had an example where we had to swap kth node from the beginning and kth node from the end. If you go back and look at that video, you will find an edge case there where p1.next was equal to p2 and we had to swap p1 and p2. So this problem is basically a subproblem of that, or you can say that this problem is also similar to reversing nodes in k groups where k is equal to 2. So we don't need to use the logic used in reverse nodes in k groups, because we can simply use some simple pointer updates that we saw in swapping the nodes in a linked list. So let's have a look how we can solve this problem. So here we have node p1 and p2 and we need to store p1 previous and we have stored p2 next. So if we want to swap these two nodes 1 and 2, what we need to do is first we need to update p1 previous dot next as p2. So this dummy node is going to point to node 2, and then this p2 dot next will point to p1, and then p1 dot next will point to p2 next. And after doing this, we are going to get our list in this state where node 2 is at the beginning now and node 1 is here and node 3 and node 4 are as it is. So in the next iteration we have to swap nodes 3 and 4. So in the next iteration I have to update my pointers p1 and p2 and also p1 previous. So first I'm going to update p1 previous as p1. So I need to do it before updating my p1 because I don't want to lose the reference to p1. So I update my p1 previous as p1, and then I can update p1 as p2 next, and then I can update this p2 as p1 dot next, and we will keep on going till we reach last few nodes. And if the length is even, then we would be left with a state where p1 and p2 are both going to be null, and if the linked list is of odd length, then p1 will be not null and p2 will be null. And as we are iterating over the linked list, what we can do is we can have a while check where we check p2 is not equal to null, and inside this while loop we do these 3 pointer updates here, and after that we set p1 p2 and p1 previous for the next iteration, and at the end we simply return dummy.next. We are returning dummy.next because the head of the linked list is going to change. So here, as you can see, the new head is node 2 and dummy.next will always give me the head of the modified linked list. So I hope this made sense, and now let's have a look at the code implementation. So here we have to implement this function swap pairs. So what I can do is I can initially create my variables. So first I need to create a dummy node. So here I have dummy equal new list node -1. Then I can set my dummy.next equal to head, and what I can do next is I can create p1 previous and set it to dummy. Next I can create p1 as head, and then I can have my p2 as, so I can check if p1 is not equal to null, then p2 is going to be p1.next, else it is going to be null. So this is because linked list can also have just one node, and in that case my p1 will be head and p2 is going to be null. And if head is null, then p1 p2 are both going to be null. So in my next step, what I'm going to do is I'm going to have a while loop. So while p2 is not equal to null, and at the end I have to return dummy.next. So in my cases where linked list length is just 1 or 2, so if linked list length is 1, then p1 will be head and p2 is null, and this while loop is not going to work, and I can simply return dummy.next. And if my head is null initially, then p1 p2 are both going to be null, and then again this while loop is not going to run and dummy.next is going to be null, and we simply return null. So this code structure is going to work for all the edge cases. So what I can do inside the while loop is I can create p2 next and set it to p2.next. Now next what I can do is I have to update my p1 previous dot next as p2 and p2 dot next as p1, and then p1 dot next as p2 next, and have to update my p1 previous first. So my p1 previous, what it's going to be, let's have a look at the diagram again. So p1 previous is going to be equal to p1, and my p1 is going to be equal to p2 next. p1 is going to be equal to p2 next, and my p2 is going to be equal to p1 dot next. So this is only when p1 dot next is when p1 is not equal to null, then I can set it to p1 dot next, else it is going to be null. So let's try to run it and see if this compiles. Okay, there's a compilation error. Okay, well, it's saying list node p2 p1 is not equal to null. Okay, what's the compilation error? p1 is not equal to null, then it's, oh yeah, b colon here. So let's try to run it, and yeah, that works just good, and let's try to submit it, and yeah, it works as well. So I hope this made sense. This problem would be more clear if you solve that swapping nodes in a linked list. And if you have any doubts, let me know. You can add in the comments, and I'm regularly creating linked list videos, so please like and subscribe my YouTube channel, and I'll see you in the next one. Thank you for watching.